Boat problem. Let us take the two horizontal parallel red lines as the banks of a river. Then small d, the perpendicular, is the width of the river. Here we are representing u, v as the speeds of a boat. U is the speed of water and v is the speed of boat. It is represented as u is equal to velocity of water with respect to earth. V represents the velocity of boat with respect to water. Then v plus u represents the velocity of boat with respect to earth. So when a boat heads perpendicular to the banks, here in this case the vector v is directed towards B, which is perpendicular to the banks. So it is heading perpendicular to the banks, but actually it travels along AC with a velocity v plus u. Because of the flow of water. The water drifts the boat towards sea. By the time the boat reaches the other bank, it reaches the point C. So the distance BC is moved by the speed of water. This is known as drift of the boat. Like this we have to study the boat problem. Crossing the river perpendicular to the banks. Here u is the speed of water with respect to earth. V is the velocity of boat with respect to water. When the boat is directed at an angle theta such that sin theta is equal to u by v, if the boat is heading up the stream at an angle theta with the perpendicular to the banks such that sin theta is equal to u by v, then only the boat travels along the perpendicular to the banks. So it should head up the stream with some angle so that it may cross the banks perpendicular to the banks. Time of crossing and the drift. Time of crossing is d by v when the boat heads perpendicular to the banks. When it heads perpendicular to the banks, the perpendicular distance is d, the velocity in the direction is v, hence the time of crossing is d by v. And the drift BC will be equal to u into the time t. U into capital T gives the drift when it heads perpendicular to the banks. While crossing perpendicular to the banks, the resultant velocity perpendicular to the banks will be square root of v square minus u square. The resultant velocity, because it heads up the stream by an angle theta, hence the resultant velocity perpendicular to the banks is square root of v square minus u square. Hence the time of crossing is d by square root of v square minus u square. This is the time of crossing. But capital T will be the least time, and small t is the time taken along the least path, and B into capital T is the drift of the boat when it heads perpendicular to the banks.